So one of the applications of differentials is using it to make approximations. So for example, we have this function, f of x here, and we do not have the equation for it. We just have the graph. Sorry, that's not the derivative. So this is our function f of x, and we want to know f of 1.9. So, that's this value right here, which we clearly can't see from the graph itself because it's just not that good of a graph. But we can use the tangent line approximation. So notice that f of 1.9 is the same thing as f of 2 minus negative 0.1, because I do know the value right at 2, okay? So instead of actually finding this other y value, what we're going to do is create the tangent line, okay? And so here's the slope times dx, and we'll just use that linear approximation, okay? So that's what we're going to do right here. So we're going to use that tangent line approximation, and we'll do f of x plus the derivative at x dx. So that means that we need to take f of our x value that we do know is 2 plus the derivative at 2 times the dx, and that dx is this number, how much we're off. Okay, so that's what we're going to plug in. So now we're going to look at this graph, and we can clearly see that f of 2 is 1. And then we need to estimate the slope of that tangent line, and I know I cannot draw a straight line with this tool for anything, but I think that the slope looks like negative 1/2. That's what I'm going to approximate it as. Okay, so basically what we're doing is we're finding the y value on this line, okay, rather than finding it on the function. And we're just going to say the line is close enough to the function, it'll be a pretty good approximation. So when we put that in the calculator, we get 1.05. Okay, so that's the y value on the line, which is pretty darn close to the y value on the actual function. All right, let's try it for another point. I'll switch colors so you can kind of see this. This time we're going to find the y value at 2.04, which is down here somewhere. Now, we don't know that, so we're going to use the line to approximate it instead of this tangent line. So we're going to split it into 2 plus 0.04, and then use this tangent line approximation. So we're going to go from the point at 2 plus the derivative at 2, the slope at 2, times dx, that's how much we're off by, 0.04. So clearly f of 2 is 1. We said that the slope at that point, it looks like negative 1/2. And we're going to plug that into our calculator, and we get 0.98. Okay, so that's the number that's the y value from the tangent line, which is pretty darn close to the y value on the actual function itself. Okay, so that's one way we can use differentials to make some approximations. Let me show you another one that's actually really handy. We want to use differentials to approximate the square root of 16.5. Now, clearly, we can't do the square root of 16.5, but we're thinking about, so our function, let's let our function be just the square root function, because that's what we're trying to do, is take the square root of 16.5. Okay, we want to find f of 16.5. Now, we don't know the square root of 16.5, but we do know the square root of 16. So we could just say, look, we're going to find the square root at 16 plus our dx is going to be 1/2. So using that same formula that we did up in the last problem, it'll be using the tangent line approximation. We'll take our approximate at f of x plus the derivative at x times dx. So we want to find f of 16 plus the derivative at 16 times our dx, which is 0.5. So f of 16, that's just plugging it into our function. That's the square root of 16 plus the derivative at 16. We should probably find the derivative. The derivative is going to be 1/2 x to the negative 1/2, which is 1 over 2 root x. So when we plug in 16, that's 1 over 2 root 16 times 1/2. So when we finish out this problem, we get 4 plus 1/8 times 1/2, which is going to be 4.0625. So we have found that the square root of 16.5 is approximately 4.0625. And what we did was we took a square root function and we said, look, we can find the square root at 16, and then we'll use the tangent line approximation to find at 16.5. And we'll just say, look, it's close enough. Okay. So that's one way we can use differentials. I think you'll see some of these in your homework as well with the square root function. We'll see one last application in the next video.